Yeah, hello. We thought we were gonna start by talking a little bit about height sensors and how height sensors work in flat material. That they work in the Z direction, up and down, only in the Z direction. Of course the jet can be tilted, but still the height sensor works in the Z direction, up and down. We're gonna look at cutting a small program here. Of course, the material does not need to lie completely flat. The material can be at an angle, and the height sensor will measure at this angle, but will still adjust only in the up and down direction. But we need to adjust perpendicular out towards the material.
Good explanation there, Jasper. To show this, we have made a fantasy part that we want to add the toolpath on, and try to explain the sensoring, 3D sensoring thing. I will start with just making a toolpath out of this. So we start here, we add a toolpath here, start here, all the way around that direction, and that will be the bottom line. So a lead in and lead out, something like that. And we then go to next, we probably go here, start that direction. That is the bottom, lead in, lead out, like that. I will change that to a fixed angle, like that. Okay, and then we have the final one. It's this one. Stop here, start here, and we go all the way around that direction. That is the bottom, and we need to change the lead in plane like that, something like that. Okay, so now we have a toolpath that we can try on the machine. Before I do anything more, I will change the distance for the lead in, for the rapids. There's no need to move up all that way. Okay, so I will now show how this can be cut in the machine. Thank you. Okay, now we are back in the lab again. We have a little workpiece here, which is very similar to the part we have seen on when we make the toolpath. So we will just see how this will work. Okay? As we will see here now, the distance to the material between the nozzle and the material is quite the same. It's around 3.5 millimeters or something like that. So that will work quite good. So this cut is a straight cut. Okay, and now we go to the next cut. I can see here that the distance is probably a little too high, because the model is not 100% perfect. I think we have a standoff of 5 millimeters here, and this is also quite good. It's around 3.5 millimeters or something. I think it's doing its job. It's quite good. Okay, we will now make it a little more complicated, because we will remove material on this side. You see this become red, and we will add material on this side. So now this model is completely different, but we will use the same CAD model because maybe the part in reality are they are a little different. So we will also be able to handle that. Yeah, now we are back in IGEMS again, and here is the part with the toolpath. We need to modify this to and add the 3D probe points. And I do that from the toolpath command. Here is a command called refpos. This I will use. I will put a point, for example, nearest that one, nearest the toolpath here, like that. So that is now on the surface. But I also need to modify the vector, and the vector should be perpendicular to that one. So now we can see here that this probing point is in that direction. Okay, that's good. Then we close that and we go to next toolpath, and then we go in here and say my position could be in the center of that hole, for example, like that. And the probe position is good. The vector is good. Okay, and that's fine. We will also add a new one to that here. We go that in the center of that one. You see it's correct, but we need to modify the vector direction. Should be in that one. So it's depending what I point on. If I point on that, I will have that direction. If I point on, for example, that one, I will have that direction. So I can control that. But now this is the one I want to use. Okay, there is also something called displacement and probe direction and tool direction. I don't do that right now. We can maybe go on that later. Okay, thank you. Okay, now we will try to see if we can cut this without any problem with a nozzle break or something. So we will start up program, and first machine will go down to the probe position, and here we can move the nozzle in this direction of the vector. So if I use this hand wheel, you see I can move up and down, and I will move this to about, I guess, 3 millimeter. I think that looks good. That's okay. So this is our, let's say, manual handling of the height sensoring, 3D height sensoring. So we are moving on a correct distance, even if we have added about 10-11 millimeter here. So let's go to next hole. You remember I told you that it was maybe a little too, this surface was maybe a little too low, but that's no problem now because we can modify the height. I think this is a good position. So we can cut that. That's very good. And here, the same, we need to use the hand wheel to move up or down, and of course in this case it will be down. So we can see that if this is a good position, and then we press OK. And the nozzle stays on that distance. Very good. This thing off. Sure. Okay, that was about the.
By the way, Bo,
What is it?
we have a new invention also. We have this gadget, which you mount onto your mixing tube, and it will automatically find the correct height for you, so you don't have to make this manual adjustment towards and further away from the workpiece. So it attaches to the mixing tube, like that, to a known height. This is like a probe, so when it activates, this LED turns on and it sends a signal to the CNC to let us know that we are now at the correct height.
Okay, so it do this job automatically. You don't have to be there with the hand wheel.
Exactly. If you have a lot of cuts and so on, you can automate this process instead.
Okay, but then we need to modify the post processor, so we probably do the censoring of all height in the beginning of the program.
Yeah, exactly.
Yeah.
Probe all the heights first,
Yeah.
make a stop, remove this sensor, and
then-
then go to all the stored or saved positions.
Oh, that's excellent.
Yeah, it's perfect.
Good idea, Jesper.
Thank you.